Welcome to the Land of House YouTube channel. I'm Seth. This is the Vestwoods 8 kilowatt hybrid inverter, and it is coupled with the Vestwoods 15 kilowatt hour lithium iron phosphate battery. In this video, I'm going to be installing this inverter and battery, as well as wiring up everything here in my critical loads panel so we can do some testing with this system. I'm excited to get started, so let's go ahead and jump into this project. This is the Vestwoods 8 kilowatt hybrid inverter. It's able to work off of solar power, battery, the grid, and a generator. Lots of different options here. So let's kind of do an overview of the unit. Over here, it's got some cooling fans which will pull air into the back of this unit. And it will also eject that air over here. Kind of hard to see, but there are some slits that will allow the air to pass out. It has the PV on-off switch right over here, so you can turn that solar on and off. Here's your on button. It also has a display up here, which has tons of different menu options. We will get into those once this unit has been installed. So if you look down here on the bottom, it has some different options for cables. Here is your battery right there. It has the COM port right here. It has a ground right over here. And then you've got COM 1, 2, and 3, which we'll be using, I believe, just number 1 there in my install. If you move over to the back here, you can see it's got the PV positive, PV negative. This has 4 different MPPT charge controllers, so you can put 4 different strings of PV in here. Has a generator, has a grid, and it has load 1 and 2 right there on the end. The panel here takes an Allen wrench to be able to access the inside. I've already loosened these screws so we can get this off of here. Whenever I pop this panel off, let's go ahead and look into here to see what all we have available to us. Over here we have battery positive and battery negative. There are 4 different bolts you can use for this. The little plastic cover just pops off so you can access those. We'll be using that here pretty soon. Over here you have 6 different Ethernet ports. This one right here is the BMS, so that will be an Ethernet cable that goes down to the battery. And the others will either have one of these connectors to measure either a generator input or your grid input, or different communication ports up here as well. Moving over here, you have your 4 different PV inputs, positives and negatives along there. Over here is your generator, load 1, load 2, neutral. You have your grid, load 1, load 2, neutral. And then you have your outputs, load 1 and load 2 over here. In order to put the wire in, you have to have a screwdriver to press down on these orange tabs, and it opens up a spring-loaded piece down below. Now down here on the bottom is your ground bus bar. So you have to put your ground wires down in there. This is a split phase inverter, so I'm just going to be using load 1 with my L1, L2, and neutral on that section. I'll also be using the grid and then of course the input from the solar as well. So let's go ahead and turn over to the battery. This is the Vestwoods lithium iron phosphate battery. It is a 280-pound battery that is designed to speak with the inverter that I have here. So this unit does come with the dedicated cables to attach to the battery. If I move over here, you can see it has the P plus and P negative. It also has 2 different COM ports and a power button, and over on the side is a ground. The unit is very heavy, and so I'm going to be mounting this here right on the ground, but it also comes with a very thick gauge steel wall mounting plate. I would definitely use this on a very sturdy wall, or else you may have some mounting issues here. This unit came in a large crate, and I was able to use a dolly and a friend of mine, and we got this up the stairs and into the house here. But I don't recommend that you move this around much because it is very heavy. I have done a few things to install this without you. The first was I painted a 3/4 inch piece of AC plywood, and I got that hung up on the wall, mounting against 3 different studs because this inverter is 100 pounds. I also needed the extra space to be able to install my critical loads panel and also some breakers down here as well. So that's why I did the plywood. I also used a product called Unistrut, and that is the metal channel that's back here. And it was able to support the weight of my inverter here and span across all three of those studs as well. So I also used my car jack on some 2x6s to lift this unit up, and I was able to hold it into position to get those nuts and bolts started where I needed them. So if you have to do this project alone, that is one way. Maybe not the safest way, but it certainly worked. Definitely use a friend if you have one available to you. I also went ahead and hung up my critical loads panel. So how this is going to work, I have got my battery down here, and so power is going to come into the unit from solar over here on the PV inputs. This unit is going to take that power and store it into the battery. When the battery is full, it can also use that power to feed this. It's the critical loads panel. So I'm going to be removing some circuits out of my main house panel over here and putting them in here. And so this system will be dedicated to this panel until the battery drops low. Once that happens, this will have a switch in here that clicks over, and power from the grid will be fed into here, and then this will feed this panel. So basically bypassing the inverter setting and just letting the grid power run this critical load panel. So it has a 10 millisecond switch in here, so even my computer should be just fine using this to power the inverter, power the circuit, and then once my battery drops low, it just flips over and runs off of regular grid power. So the wiring for that is decently simple. Solar is going to come up through here, and that's going to be where it stops. I'm going to have wires, 8 gauge wire on the load 1, the L1, L2 neutral, and that's going to come out of the inverter up here into the bottom of my critical loads panel, and it's going to feed both legs here. So 240s coming out as split phase, 120 each, so it will feed both sides here. A single neutral will go into the bus bar over here. These should be linked together to provide the power for that. I'll have a ground going over here. All of my breakers will be in this panel attached as if they were over here. And then I will have grid power from over here on a breaker come into the inverter, and that will kind of make that full loop there. And that's what we have to do today. So we're going to start off by knocking out the 2-inch down here, 2-inch up here, and the fun part is going to be knocking out the 2-inch up here to run the power from here up and over into the top of this panel. So let's go ahead and begin this construction. I'm using 2-inch flexible conduit, and the reason for that is because all of these breakers from about this point down will need to have the wires moved over into the critical loads panel. So I'm going to be using some Wago connectors to take these wires up, over, and down. And so I have to have conduit big enough to support all of those wires. I'm also going to have the grid wires that will be coming from a breaker on this panel, and that's 8 gauge. And I also have the 8 gauge coming from over here, which will go through as well. So with all those wires, I decided 2-inch is going to be the size that I need. So first of all, let's knock out this bottom right down here. I need a 2-inch knockout there, and that's just going to be for one of these. It's going to pop right there. The hose is going to come down and over and take the wires. I just have 6 wire in there, and then up here I'm going to use these 90s, like this one right here. So that needs to be in the 2-inch knockout there. We're going to have to drill in with a hole saw here and bring this out so that that flexible tube can reach from here to there. May have to pull out the heat gun to get that flexible hose bent enough here. All right, looks like I need that second to largest ring right here. Well, that was quite a stubborn knockout, but I finally got it. All right, so I'm going to use this adapter here to go from the box into my flexible pipe here. So slip that on like that. And then this piece will go on the other end. Now this piece right here isn't really necessary. I'm just wanting to keep the wires looking neat and tidy. Place this up in here, put the locking nut on. I want my conduit pipe to stick up here a bit, so I've got one of these little mounts that I'm going to just put on the end. So I can kind of twist this up here, get this screwed into position. All right, that's done. It just kind of keeps that wire up from right over here, up out of the way, and goes safely into the critical loads panel. All right, my next task is to spend time knocking out the 2-inch here and the 2-inch over here. Now this one was super stubborn on the bottom, so I'm gonna just work at it until I get the hole here and the hole over there, and bring you back as soon as that's done. I've turned off my house power, so this breaker panel here no longer has power to it. And I need to knock out this piece up under here. And so I think what I'm going to do is go ahead and cut a 3-inch hole using a hole saw here. And I may offset it just slightly because I want this to bend that way. And so it looks like I need it to be about right here. I can always use a sheetrock knife to expand this hole size if need be. So I'm going to go slow. There shouldn't be any wires there. I think I'm going to cover some stuff up here. It's too much dust. Luckily, the cavity back there seems to be pretty well empty. I may have to go up a little higher there on my hole to make sure this fits properly. Okay, that looks good enough for me. I just stuck that little 90 down in there and tightened it up, and then got this one over here tightened, and then put this piece of flexible conduit in between, and that's going to be good enough to connect the two different panels together. So my 12 and 14 gauge wires here for these breakers will go up into that hole, circle around, and come out here to be attached to this panel. Now that I have the conduit installed, it's time to begin running the wires. I have red, black, and white 8 gauge wire, and this is going to be put onto load number 1, and it's going to have the 2 legs of hot and 1 neutral on the split phase 240. And that wire is going to come up here, black over here, red over here, neutral right here, or whichever direction I go on here. It's going to be the same. Now I also need to run a ground, and because I only have 12 gauge wire, I'm going to double this up and run from my little grounding terminals down here up through here, and that will go on this separate bus bar over here. Now the ground does not need to be connected to my house panel. It needs to go outside to its own separate grounding rod. Let's start off with our red wire. I'm going to fish this down in here to the conduit and take this out here. Now this first gland right here is load number 1, so I'm gonna pop that up through there, and we will connect that in just a moment. So I'm gonna leave this here. We'll snake it up here to one of these terminals in a moment. Let's now move over to the black wire. All right, slide the black down there as well. This also needs to go up into load 1. And then also the neutral wire. Okay, my white, black, and red wires. I need to strip back some of the sheathing here. I'm going to go somewhere around a 1/2 inch on that and just get it stripped down. All right, let's go ahead and begin with the neutral wire here. This is going to go in the rightmost side. So if I get this lined up here, now there is a little orange tab that I may need to press on the top to get this to push in here. Let's see if it'll do it without. Okay, yeah. So I was able to push that in there, and so in order to release it, I would have to press that button there. So, all right. We'll do L2 as the black wire here. I know my hands are in the way, but hopefully that makes sense to you. All right, so got that pressed in. And then the last one is the red wire there on L1. And now moving up here to the critical loads panel, I'm going to bend my wire down so I have extra to work with. Come up here and let's see, we can cut this about right here. Once again, get this stripped down. I think about a 1/2 inch should be fine. Get that wire pressed in there and then just tighten it down. That takes care of the neutral. I'm going to do something similar with the black and red. So let's just go ahead and dedicate this side over here to be the black wire. So about right there should give us more than enough room. I'm wiring this up to the top lug here, so place that in, go ahead and tighten it down. Nice and tight. And then lastly, I'm going to do the same thing with the red wire. Go down on this side over this way. About right here. As a quick recap on that step, I have the red, black, and white wires coming out of load 1. Those go down through my conduit into the new box. The neutral wire does go over to this bus bar, which has continuity with this one over here. Then I have the red and black going up here into the top of this breaker panel. The next step is to attach 2 of my green wires to these screw terminals back here. Also run them through the L1 up here, and those are going to go over to, I believe, this one over here. The grounding bar back here is connected to the chassis of this inverter. So in order to get the first and second grounds in here, I'm just running my wire through here. I've actually already run the first grounding wire just to get that out of the way. So run this one down here. Feed this on up here. I simply put a loop in my wire and then use the bolts that came onto this grounding bus bar and just got that attached there. And then lastly, I'm going to move up here to my panel, similar to how I did with the other wires. Find the length that I need to go up under here. And let's see, so somewhere around right here. Trim that down. Now that I have the wires run from the inverter to the critical loads panel, I also need to run the wire that goes from the main panel, bypasses the critical load panel, and goes to the inverter. So whenever the battery drops down too low, this circuit will kick on and will power this through this. Now I'm also going to be using a 40 amp breaker. So the wire that is connected to the breaker will then go into the bottom of my main house panel, and that's going to be turned off right now while I'm wiring things up. So, all right, let's go ahead and pull the black, red, and white wires from the inverter up through the top conduit up here and then down into the main house panel. For the sake of consistency, I'm going to start by pushing my wire down into here. And then I'm going to go back into my 2-inch conduit down here. Luckily this stuff is pretty smooth and it slides the wire in pretty easily. Hopefully it stays easy to work with as I push it through this top sweep up here. Let's see how well that's going to work. It is hitting a bit of a snag up there. I ran the red wire up there as well. It went a lot smoother. I guess it was pressing against the black one as it traveled along. So last one I want to put up here is the white wire. So I'm going to follow along here. Same path as the other two. I won't bore you with this process again, but I'm going to strip down these 3 wires and put them into the grid holes over here. So we got L1, L2, and neutral. I now have my black and red wires over here by my main house breaker box, and I've got that 40 amp breaker. So I need to strip these down and get them into the breaker. So once again, stripping back about a 1/2 inch here. Now I can arrange these a little differently later if I need to, because I'm going to be moving over my breakers here to the new critical load panel. But for now, just going to get these in here. So I've got the breaker turned to the off position, and I'm going to get the red and black wires put into the breaker. There we go. Those are nice and tight. And now I can actually get this put into my breaker box here. Now it is live back here in the back, so I want to make sure I don't touch anything. So tracing that wire, I've got the red, black, and white there, and it just goes down into my conduit, up here, bypasses over, goes up and around, goes back here on the back, and then down into this lower breaker here. And then I have the white wire here still, and that is going to go into the bus bar back there. I'll wait to do that whenever I have pulled out some of these other breakers and it's easier to get to. This is my disconnect or breaker box for the solar and the battery. So I'm going to have my red and black solar wires coming up to the bottom of this breaker and then leaving up here to go on to my charge controller. And I also have a Midnite solar surge protector device, and that will have the red, black, and green wires to protect the solar side of my system. Over here is a 250 amp breaker. So I'm going to have the positive wire of my battery coming up to this terminal here, goes through the breaker, and then out up here onto the inverter charge controller. So let's go ahead and mount this right here. I do have to have the ground coming in here. It's going to pass through, and it's going to attach to the surge protector, and then it will continue on down outside. My electronic system is right past this wall, so I am going to be installing this grounding rod right here next to the house, and I just need to set this here and then begin driving it down. That's about as far as I can push it by hand. Let's go ahead and hammer this in the rest of the way. I just brought this heavy maul here. Now this is an 8-foot rod, and so I'm going to try to get this down to within an inch or two from the bottom. I'm going to mount this right down here. And now with the breaker box installed, I'm going to run this double ground wire down here. Let's go ahead and get the positive battery cable attached to the inverter. So I've got over here is the battery positive. I'm going to unscrew that terminal there, stick the battery cable up in here, line that up with the threaded hole there, tighten that down. I may come back with a socket set and make sure that's really tight, but for now, just gonna keep it as a placeholder there. Now this battery cable needs to go into my breaker box here, and so what I'm going to do is just kind of have this cable come down, sweep over, and I need to cut it so it will go inside of this box and loop around right in here. So I'm going to give this a little extra space, so cut about right here, and that will allow me to go into those lugs. Just got some big wire cutters here. There we go. And now that lets me use the other side of this cable to go down to the battery. I need to strip this cable down real quick. I also wrapped the cable with some black tape to make sure that there's no issues with this rubbing against my plastic box here. So I get all those fibers into that battery terminal. The other half of the positive battery cable is going to go onto the bottom, and that is going to be directed toward the battery. The positive cable is done. Now it's time to move on to the negative. So I'm going to press this up here as well. Line this up here and replace this. Okay, very good. I'll come back later and make sure those are nice and tight. I think I don't want this to kind of follow the same path here. I may even have it go behind the other one so that it will be tucked up here nice and evenly. Something like that. Now I also need to have the communications port, which is this right here. It's just an Ethernet. And let me find which gland is the, let's just do COM1 right here. So communication port right here for the battery goes right here. It's the BMS, so it's going to be on this position. I'm going to call it number 1 right there. All right, very good. And this can also follow the same path here, as long as it has enough reach to get down to the battery. And now, for the sake of keeping my cable management together here, I'm going to put all of these right next to each other, and I'm going to wrap them with some Velcro to keep it here alongside my other conduit pipe. To go from my solar disconnect up to the inverter, I have 10 gauge stranded wire that I'm going to install. Now I want this to be hidden, so it's going to go from the breaker box down here up and through the 2-inch conduit and then into the inverter over here. So let's go ahead and do that right now. I have a small section of 1-inch conduit that's going to bridge this gap and hide the wires. So first of all, I want to place my 10 gauge down here through this gland, kind of where my ground wires are here. I'm going to match those up, and I've also got another little gland fitting right here that these are going to all fit into. And then now I can take my little section of flexible conduit here and place that over here. Okay, and now it's just a matter of getting all of this stuck into my little breaker box here and tightened down. So I'll bring you back in just a moment to finish up the rest of this. Okay, I got those wires installed to the box and stripped down. Go ahead and place them into these breakers and then just tighten that down with a screwdriver. Now that I have these wires up into the box, I'm then going to hopefully get them pushed down into the 2-inch conduit. See how well that works. Now it's time to get the wire into the inverter. Over here is the PV positive. I'm going to go ahead and push the wire up into that. And then the next one over is the PV negative. Get the wire pushed into there. And then I have to strip down about a 1/2 inch or so off of the end of that. Now these wires have to be pushed into these terminals. So over here is PV1 positive. You skip over a couple and here's PV1 negative right over there. So those are the two I'm going to be using. So red, of course, is PV positive. If it doesn't want to go in, I can use a little tiny screwdriver to press that tab. But it seems like it has made a pretty good connection in there. Now move over to PV1 negative. Press that wire in. Got the red and black coming in here. They circle up and go into the box. Now there's plenty of extra in here if I have to make adjustments later. That then circles down into the 2-inch conduit and comes over here into the PV1 positive, PV1 negative. Now that I have those wires all installed, I am done with the panel, so I can return the Vestwoods front panel here and get everything screwed back into place. I've run some conduit to the bottom of my breaker box here, and that's to house the other half of the ground wire and also bring the solar wire up from outside. Now, in a separate video, I'm going to have a little bit of information on this device right here. This is a surge protection device, and so check the links in the description down below for how to install that. But basically, it will go right up under here and it will help protect from lightning surges. To be consistent with my other ground, I'm going to run 2 of these outside to my grounding rods. So I need to get those pressed into this 1-inch conduit here. I drilled a hole through my foundation and got these double ground wires out here to the outside grounding rod. And now I'm going to make sure that I have plenty of exposed metal touching here. And I'm just going to tighten this up onto the grounding rod. There we go. Makes a good solid connection there. Now it's time to connect the communication port here. I'm going to open up this little rubber stopper. Might be a little hard for you to see there. And then I'm going to just plug that in there. And then I'm also going to connect the positive and negative battery cables. So the orange one here is going to be PV1, and the cable only has a specific direction that it will go into. As you can see, the communication port is up there in the top. I've got the battery cables where they need to be, right there. And then lastly, we have the on button down here. I just finished getting a couple of things done without you. Number 1, I installed 3 kilowatts of solar panels outside and got those hooked up in here to my little breaker box. I also managed to get the communications cable working between the inverter and the battery. Turns out I had to cut a couple of the wires in that data cable. The company is going to be fixing this issue before these are shipped out commercially. And then lastly, I have tested out my critical loads panel up here, and it is also working properly. All right, go ahead and turn this on. Got between 10 and 13 amps right now. That means it is now time to move over one of the loads here in my main house breaker into the critical loads. I'm going to be using Wago connectors. If you've never seen those before, they look like this right here. See if I can bring that up a little closer for you. Anyway, they basically have a tab that opens up. You stick your wires in there, you pop that tab down, and it's like a wire nut, except it is a straight connector instead of having to twist into those wire nuts. I have also gotten some piece of this Romex rubber, and I'm going to have labels here. So whenever I pull a circuit out of my main panel, I will slip this over the wire. And so if for some reason I need to revert a circuit later over here to the main house panel, I can easily find out which wire goes where and don't have to do a bunch of testing with a multimeter. 3 kilowatts of solar power comes in through here, goes to this breaker, which is on this side over here, and then it goes up here, circles around, and goes into the inverter over here. I also have turned on the PV switch. Now it's getting dark out. The battery up here is at 98%. And if I go into the settings here, let me see if there's any watts coming in from solar whatsoever. Nope, so it's too dark. Solar has stopped. For my example, I have the freezer and refrigerator circuits right here. I'm going to flip these off. I'm going to pull the breaker out, and I'm going to look at the wire size. I have a spool of 14 gauge and a spool of 12 gauge. So whichever wire I need, I will be using that to match what is currently in the house right now. I will then run my critical load wire up and around so that I can connect what's in the house to the new wire here using those Wago connectors. And then I will simply take the breaker that's here and snap it in over here. And that will just allow me to have this feed the house circuit. And if the battery drops too low, the inverter will click over, I think it's 10 millisecond or less, and it will pull grid power over to the inverter, which will then power this off grid instead of the solar. So let's go ahead and turn off the freezer, which just happens to be the one in here. And then that one right there is the refrigerator. All right, I just simply pulled an extension cord so I can pull this out here. Now keep in mind that I'm doing this with the power still on, so I'm going to be careful not to touch anything. There we go. And I'm going to go ahead and remove this wire and see what size it is. All right, I believe that is a 12 gauge. I'm going to place this Wago connector onto the wire. This is my refrigerator indicator. I'm going to slip that over the wire. Press this back in full. All right, good. Made a nice solid connection. I'm going to start feeding this black 12 gauge wire up here through my conduit. Hopefully it makes a nice smooth transition over there. After about 20 minutes of trying, I finally got this wire to go up and around here. How much wire would I need to get down here? So a good bit, it's a couple feet. I think I have about 70 feet of wire maybe. I actually made a bigger loop in this 112 gauge wire and managed to get it over here individually just so we can wrap up this quick critical loads install. So, all right, let me go ahead and show you here that I'm going to move this wire here, which is the refrigerator. Okay, got that done. This 12 gauge wire right here is now connected to the refrigerator of the house. So I can bring this down over here. Let's bend this into position like this. And we'll go ahead and trim this wire down just a little bit. Can strip off that wire. I'm going to reattach this to the breaker. And now I'm going to attach this down here on the very last one of these. Make sure this is still off. With the black wire wired up into this breaker, it's time to also get the neutral from the same circuit pulled over. So once again, just for video purposes here, I'm going to run a single wire over, and then after that I will pull all these together without you, but just wanted to show you here getting this one circuit installed. So all right, so just bringing over this neutral wire, and I need to locate the same refrigerator circuit neutral that's down here, use the same Wago connector, and then connect this over here to the bus bar. Now this side and this side are both linked together, so I can tie into either one of those. All right, let me locate this one real quick, and I will bring you back in just a moment. Okay, this is the wire coming down from our critical loads panel. I'm going to snap one of these Wago connectors on there. Very good. And then I found the refrigerator neutral here. So I'm just going to press this all the way in here, lock that down, give it a little tug. Seems to be good. So now I can move over here to the neutral of the critical loads panel and get this connected. I'm just going to kind of bend things up out of the way, strip down this one by, I don't know, ½ inch or so. I've made sure that the breaker is still off for the refrigerator circuit here. And there we have it. The black wire going to the refrigerator is connected here. The white wire to the refrigerator is connected there. And so both of these go to the new critical loads panel, neutral to neutral. I've got the breaker here, which is just a 120, going to that side over there. And so the inverter actually is on and prepared for this. Let's go ahead and flip this on and see the refrigerator working in here. There we go. The light is on and the refrigerator is now working. Here on the inverter, you can see load 1 has 153 watts going out, and that is the refrigerator now working. As you can see, moving the circuits over from the main panel into the critical loads panel is going to take some time. Let me finish moving the ones that I want real quick, and then I will bring you back whenever I am ready. Whenever you're pulling the breakers out of your main panel, something that I find very helpful is to take the wire out of a piece of Romex and use this plastic sheath here and write out. So here we are, bedrooms 2 and 3, and I also have the matching here for yellow. So I've got the orange color is going to be the black wire or the hot, and then the yellow is matching up with the negative. And that will help me greatly to trace these whenever I swap over to my critical loads panel. So what I'm doing here is basically shutting off the breaker. Now I highly recommend you do all this with your main panel off, and to do that you would just simply flip this 200 amp breaker up here. I'm being very careful, so here I've already turned off this breaker, which is for bedrooms 2 and 3. I can just pop this out, and then I'm going to use my screwdriver here to pull these wires out. Now this breaker here is a little bit special. It's a ground fault breaker, and so it's kind of wired up a little bit different. Let me show you here. So pull out this black wire, which is the hot wire. Okay, and I'm going to put that piece of Romex sheathing on there. So I know that's bedrooms 2 and 3. And then I'm going to make sure that I have that connector nice and flat. Get a Wago connector here. All right, it's good and tight. And now I also have to pull out the neutral from this same breaker because it's a ground fault breaker here. Do the same thing where I just flatten out that wire to make sure it goes into the Wago connector properly. Now this is the negative, so I'm going to put bedrooms 2 and 3 yellow on here. Use this Wago connector. Nice and tight there. And now this ground fault breaker needs to be removed. So it's connected up here to the negative bus bar. So I'm going to trace that back up here. Looks like it's the top one. Get this out of here. All right, so this will go into the other breaker box. There you go. So just keep in mind that adding these little plastic tabs here is super helpful whenever you move these back over. Now, if I bring you over here to my critical loads panel, you can see I'm doing the same. So for instance, I have the refrigerator right here, and I've already got it hooked up and tagged and working. Same up here with the negative, I've got that as well. So I'm going to have basically these little pieces on both sides, and I'll also have these written on my panel lids to know what is what. So keep that in mind, makes things a lot easier. I finally got all of my critical loads moved over to this new panel, as you can see right here, and everything has been working very well now for about a month and a half. So I want to walk through the system real quick, and then I also want to talk to you about a few things that have happened over this month and a half that you may be interested in if you're going to get one of these Vestwoods systems or a system like this. Solar power enters in through the hole right there, sneaks behind the battery in this conduit, goes through a breaker, which then goes up here, skirts around, and goes into the PV1 of the Vestwoods inverter, and that feeds the inverter MPPT charge controller. That then goes through these orange cables and gets stored in this big 15 kilowatt hour battery. The communications cable over here does go around and goes into the COM port 1 so that the inverter knows that this is a lithium battery and it knows exactly what to charge that at. So next I have grid power, which if I open up this panel here, you can see I haven't labeled it yet, but this is the grid, and that goes up here, bypasses this panel, goes down into the grid setting over here, and then the inverter then takes that and feeds it to the critical loads. So currently this is just a UPS or a backup to my house. So you can see right over here, this is the grid button that is on. And so the battery basically is not being used. Now, if I want to make this an off-grid system, I will have to cut the power from the grid here, and that will, within 10 milliseconds, turn on the battery to use just the battery system. And so none of the lights should turn off, and the computers will also stay on. So that is working very well. Now, something that has been really, really nice is the app. So this is a Wi-Fi dongle down here, and it connects to the app and allows me to check on the current status of the system anywhere in the world, as long as you've got the internet. So this right here, very nice to have. All right, so the inverter then will send power to the different lugs of this sub panel and feed these circuits based on the inverter left or right channel, and everything has been working very well. So issue number one, I wanted this whole system to basically have priority with the battery and the solar. So the solar power would basically feed this load as long as the sun's out. If the sun goes down, then the battery will then take over, and then last minute or last resort, the grid would then pull over here and run the house if need be. That's not the way this thing is working. So right now it has grid priority, and if the grid goes down, the battery kicks on immediately, and the solar and the battery kind of work together to take over on an off-grid situation. So here's my plan. I'm going to be installing a switch to turn off the grid power, and I'm going to have an additional 3 kilowatts of solar up on my hill for a total of 6 kilowatt panels, and that will keep the off-grid setting active unless for some reason I don't have enough sun for a week or more. Then I'll be able to flip the grid back on and use the grid. But it's going to basically have all of the circuits here in my critical loads panel as off-grid as possible. So that was the main disappointment that I had. The other thing was, whenever the sun would come up in the morning, the inverter would shut off for about 30 seconds and the PV would slowly ramp up, and then the system would come back on. Well, I couldn't have that with my computers and refrigerator and everything else that I've got going on first thing in the morning. So I contacted the technical support, and they went into the system here and just turned off this cushion setting, and now it's immediate. So if the sun comes up and PV starts charging, it doesn't have any effect on it besides charging the battery. So, all right, let's go ahead and do a quick grid down situation so you can see how I want this battery to perform. All right, so first note, this is my breaker, and this is on the grid setting. If I flip this off, there may be an ever so slight flicker on the lights, or a whole system shutdown. Well, that didn't work. This is supposed to have a 10 millisecond switch so that you never see a difference between the grid power and the battery power. But in this case, it shut down. I changed the mode to battery priority. It was on a different mode, so we'll see if that makes a difference. I may flip the switch here in a moment to see. Anyway, it's off grid now as the second light is on up here. It's got about 350 watts coming in because it's a very cloudy day, and the rest of the house is being supplemented with this battery. So I had run this off grid for a little over a month, and every maybe 8 or 9 days I'd have to switch back over to the grid, and that charges the battery back up along with the solar. And so I would basically build that back up. And that's why I'm thinking that if I add another 3K of solar, I will have 6K total, and I should be able to run this circuit right here off grid all the time. Now this inverter has tons of information on it. So right here I'm on the PV1. I've got 450 watts coming in. I can scroll down to the other MPPT, which have nothing on them. And I can go here to the battery. So state of charge is 98%. And then I can move down a little bit further and see the inverters. So here you got 120 volts, and it's using 1.7 and 1.5 amps on both sides. So if I move down here, you can see one side of the load is 195 watts. Down here is 150 watts. So the house isn't using tons of power. 3%, 4% on that. You can see the battery is pushing out 32 watts while the PV's got 450 coming in. And now if I want to get into the settings, I can go to setup here. The password is just a bunch of zeros. So you have to go into your battery settings, battery type, and it has to be on the lithium setting here. And then you've got to set your charging currents, your discharging currents. The battery communication here is this CAN. But after all of that is set up, it's nice to go to the home screen and be able to look at things. So typically I leave mine either on the PV1 setting, so I know what's coming in, or this screen here, so I know what the state of the charge is on the battery. I set this to battery priority. Let me run this test again. So I'm going to turn the grid back on, and we shouldn't see this light flicker at all. We'll know if I turn this light off, if it does. So here we go. All right, so grid light turned on, EPS light turned on, and these should swap over here and not have any issues. Okay, and now we're running totally on the grid. So I'm gonna give this a minute or two, and then I will flip this again and see if we have that shutdown issue. Hopefully not, now that I've turned this to the battery priority mode. Okay, I waited about a minute. Let me go ahead and flip the grid power off again, and we'll see if the battery priority mode keeps this system going using the battery as a UPS. So here we go. Let's see if it works. Good. All right, that's much better. So EPS turned on immediately, and the grid power is no longer on. And so let's see, we got 440 watts coming into the battery. So that right there is exactly what I was hoping would happen. So I just had it set to the wrong setting a moment ago. All right, good deal. There are lots of steps to installing a whole house system like this, so I hope you have enjoyed the video. If you have, leave me a constructive comment down below and I will try to get back to you. Now at the time of this filming, the inverter was not quite available yet, but the battery has just gone live on their site. So I'll have links to these in the description down below for whenever they are fully available. If you have comments, leave those down below and I will try to get back to you. And hopefully I will have a new video for you coming up next. I'm going to install a switch down here so I won't have to alter my breakers. And I can just flip this into grid power or off-grid mode. And my goal is to bring you along to show you how long this inverter will run the house off of just the solar and the battery. Now I am going to be installing that extra 3K of solar up here on the hill to give me a 6K total, and that should get me off the grid totally with these circuits. Now the things that are not on this inverter are my well pump, the dryer, my HVAC system, the hot water heater, and also the stove. Those are my 240 volt systems. So I have a separate system outside that has a grid tie limiter feature that will supplement those loads as well. So anyway, all that to say, subscribe to the channel if you haven't already, and I will see you in the next video. Bye.